Hello, today video's topic is haloalkanes and haloarenes. Haloalkanes and haloarenes. Okay. So now basically we will first start to know what basically is this haloalkane. So here halo stands for halogen and alkane basically implies any aliphatic carbon, okay, which is sp3 hybridized. So we have got a compound, haloalkane means we have got a compound in which the halogen, which is acting as a functional group attached to a aliphatic carbon. Okay. Now let us see the classification of haloalkane. Okay. Now the first classification is which is based on number of halogen. Number of halogen. So here the first one is monohaloalkane. Monohaloalkane. Okay. So we have got this aliphatic carbon group, okay, which is also known as alkyl. Now specifically this one will be called ethyl, okay, and then we can place here any halogen, okay. Let us simplify this. X stand for halogen. Now here X can be fluorine, chlorine, bromine or iodine also. Okay. So we have got a compound where only one halogen is there. Such kind of haloalkane will be called monohaloalkane. Okay. Now this haloalkane is also called alkyl halide. Okay. Now another example if I give you here, okay, CH3Cl. One halogen is there, so even this one will come under haloalkane. Now apart from this, okay, we can have dihaloalkane also. That will be the second one. Dihaloalkane. Okay. That means in the aliphatic carbon chain, if we have got two halogen, we will call what? Dihaloalkane. Similarly, if there is a three halogen attached to an aliphatic carbon group, will be called trihaloalkanes. In general, if we have got a halogens, more than two, okay, more than two in aliphatic carbon compound, will be called what? Polyhaloalkanes. Now, this monohaloalkane, okay, further this number 8 which I discussed, this monohaloalkane can further be classified as 0 degree, which is also called super primary. Okay. Here it is basically methyl halide. Okay. Next 1 degree, which is simply called primary haloalkane. That means here see the carbon, okay, on which halogen is attached, this carbon should be sp3 hybridized, okay, and the remaining substituent can be a simply hydrogen or a carbon group. Okay. Then such kind of monohaloalkane will be called primary or 1 degree, or in short prime. Next, if this sp3 hybridized carbon, okay, is attached to one halogen and has got two carbon group here, okay, two carbon group here, then such kind of monohaloalkanes will be considered as secondary haloalkane. Now let me tell me one more point regarding this one, okay, that in case of primary, okay, at least two hydrogen should be there and one carbon group must be attached there. Okay. That is the condition for monohaloalkanes to be called primary haloalkane. Okay. R basically stand for any carbon group. Okay. Next, so secondary is done here. Tertiary. In tertiary, this sp3 hybridized carbon, okay, which contain one halogen must be attached. This sp3 hybridized carbon must be attached with 3 carbon group. Now this 3 carbon group can be a sp2 hybridized, sp3, does not matter, but any carbon group. Okay, R stands for any carbon group. Such kind of haloalkanes will be called tertiary haloalkanes. Okay, so this was the classifications of monohaloalkanes. Now next, okay, apart from this, okay, we have allyl halide. Okay, allyl halide. So in basically allyl halide, okay, we have got a sp3 hybridized carbon attached to a halogen. Got it? Okay. And then this sp3 hybridized carbon is further attached to a adjacent carbon which is sp2 hybridized. That means it will have a double bond, and this one is further attached to a sp2 hybridized. Okay, and this one, this part, okay, is basically, it can be cyclic also or in simply aliphatic, but not aromatic. It should not be an aromatic. Example, if I give you here CH2 double bond CH, CH2 Cl. Okay, this is one particular example of allyl. Another example of allyl can be this one. Okay. Now apart from this, we have got another kind of haloalkane which is called vinyl halide. In vinyl halide, the carbon on which halogen is attached is sp2 hybridized. That means it will have a double bond, and this one, it should be aliphatic. It can be cyclic, acyclic, but it should not be a part of aromatic. So basically here, if I give you the example, it will be this or this. So this was about the a short brief classifications of haloalkanes. Now if I talk about another kind of haloalkane, okay, which is called benzyl halide. Now what is this basically benzyl halide? That means here halogen is attached to a carbon which is sp3, and this sp3 hybridized carbon is attached to a sp2 hybridized carbon, and this sp2 hybridized carbon is a part of aryl ring. Okay, that means this one, this is the hybridized carbon which is a aryl ring, is a part of aryl ring, and we have got this one, this carbon which is sp3 hybridized and a halogen attached. Such kind of compound will be called benzyl halide. Now next we have got, so this was all about the classification of haloalkane. Next we have got haloarene. Now if I talk about haloarene, in haloarene the halogen is directly attached to a carbon which is sp2 hybridized and is a part of aryl ring. Okay, that is, if I give you the example, this one. Okay, so this is basically called haloarene. So this was a a classification of haloalkane and haloarene. Now if I talk about haloarene, even haloarene, okay, can be further classified as monohaloarene, that means only one halogen, or dihaloarene, that means with two halogen. Okay, trihaloarene. Is that clear to? I hope it is clear. Okay, this much regarding this much point. Okay. Now next we have got preparation of haloalkane. Now if I talk about the preparation of haloalkane, now preparation of haloalkanes. Okay, if I talk about preparation of haloalkanes, the important one, okay, is important one I mean to say is that there is a preparation called reaction of alcohol with thionyl chloride, which is considered as the best method for the preparation of haloalkanes. So like from alcohol, okay, so here basically we have got an alcohol, it is allowed to react with thionyl chloride. The the formula is SOCl2. Okay, this reaction is carried out in presence of base pyridine. So here the halogen from here directly replaces the OH group, the alcoholic group here. I will basically tell you the shortcut form here. We have got an alcohol and we have got a compound which has got a halogen here. So here what we will do, this carbon part will remain as it is, the OH group gets replaced by chlorine here. Okay, and the byproduct we have got sulfur dioxide which is a gas and HCl which is a gas. Okay, what will be left out is the pure haloalkane. That's why this method is considered as the best method, and because it produces a pure haloalkanes. Now how to know by shortcut method to get the correct product, I mean the correct byproduct? So basically we have to write down the alcohol structure in this format, and we have to write down thionyl chloride in this format. So we can eliminate this one as an HCl, we can eliminate this one as a sulfur dioxide, and we can eliminate this one as a haloalkane. Okay, this is by shortcut method. Now let me discuss the mechanism of this reaction. So alcohol here, the oxygen has got a 2 lone pair. Next we have this thionyl chloride. So here the lone pair will attack on this sulfur. This one the pi electron will move over the oxygen. Okay, when it comes back, this halogen will abstract this proton. Okay, and this oxygen can be stabilized. I have reduced some step by the way here. Will be left out with this. So HCl, in this process, HCl has got already eliminated. Of course, let me tell you again, I have reduced some step here. Okay. Now next part, this one and this. So here R CH2 Cl plus sulfur dioxide, which is a gas form. I hope you have understood this particular video. Thank you so much.